All right, let's dive right into this. Close your eyes for just a second and picture the globe. Right now, at this very moment while you're watching this explainer, there are roughly 15,000 airplanes up in the sky. But if you look down at the oceans, well, the scale shifts dramatically. There are an astonishing 38,000 cargo ships slicing through the water simultaneously. I mean, 90% of all international trade, literally everything from the needle in your sewing kit to the car sitting in your driveway, travels by sea. But here's the thing. We've hit a ceiling. We physically cannot build ships much wider or deeper because if we do, they simply won't fit through the Suez or Panama canals. So this new space race of the oceans isn't just about getting bigger anymore. It's about getting smarter and getting cleaner. Today, we're unpacking the absolutely mind-blowing $200 million engineering marvel that is the CMA CGM Jacques Saudet. 400 meters. That is the length of this incredible vessel. To put that into perspective, imagine taking 4 massive professional football fields, just ripping them right out of their stadiums and laying them end-to-end across the ocean. If you were to somehow stand this ship upright, it would completely dwarf most of our iconic skyscrapers.
And the sheer mass of this thing is staggering before a single piece of cargo is even loaded onto it. We're talking 70,000 tons. To help you visualize that photorealistic mass, just imagine stacking 7 complete Eiffel Towers right on top of one another. Or, actually, if you prefer, picture a literal stampede of 11,500 fully grown African elephants. That is the deadweight of the empty steel hull alone, just floating there on the water.
But of course, it doesn't sail empty, right? This Leviathan is designed to carry exactly 23,112 standard shipping containers. Let me break that concept down for you. If you were to take every single one of those containers off the ship and lay them end to end down a highway, they would form an unbroken wall of steel stretching for 150 kilometers. It's not just a ship, it is a floating, moving, highly efficient steel mountain.
Section 1. The Ultimate Engineering Challenge. Building 9 ships. Because the French shipping giant CMA CGM didn't just order one of these massive vessels, they ordered 9 of them, sparking an almost impossible logistical timeline. So to pull this off, a shipyard in Hong Kong was chosen. And this facility is so massive, it stretches 4 kilometers long and basically operates like an independent 24/7 city with over 6,000 workers. But to build these giants, you don't just start welding. Before a single spark flies, naval architects have to go through this rigorous process called the design spiral. Every single parameter, from the proportions to the powering to the capacities, is intricately balanced. They have to ensure the ship is not only economically profitable, but also meets incredibly strict safety classifications, like those set by Lloyd's Register. Every single millimeter is calculated for maximum hydrodynamics and structural integrity. Section 2. Forging the steel skeleton. Once the blueprints are locked in, we enter the physical realm. Thousands of workers begin shaping the raw cellular material of the vessel. These are specialized rust-resistant steel sheets. Just one of these 9 ships requires 12,660 of these massive plates. And this is where the sheer force of human engineering gets kind of terrifying. You can't just cut these plates with a regular saw. Workers use a specialized laser beam running at 18,000 degrees Celsius. Let that sink in for a second. That is literally 3 times hotter than the surface temperature of the sun. This superheated beam slices through thick marine-grade steel like a hot knife through butter, precisely cutting 880 kilometers of steel strips for each ship. Now, the secret to their incredible construction speed is what they call the Lego block method. Instead of building the ship from the bottom up all in one place, they build it in separate multi-story blocks. And here is the real genius part. They pre-install all the pipes, the wiring, and the internal fittings inside these blocks before they're ever attached to the ship. Huge cranes, capable of lifting up to 600 tons at a time, then carefully slot these massive, fully equipped mega blocks together. It's exactly like a giant puzzle. But putting the blocks together is really just the beginning. The ocean is an incredibly hostile, merciless environment that forgives absolutely no structural weakness. To fuse this ship together, workers lay down 1,250 kilometers of manual welds. If you laid that weld line perfectly straight, you could walk on it from Paris all the way to Berlin. Every single joint is intensely scrutinized because a weak link means absolute disaster out at sea. Section 3. The world's largest thermos. Storing LNG. This new fleet is powered entirely by something else, requiring the construction of essentially the world's largest thermos. The reason for this immense engineering hurdle is the environment. By switching from traditional heavy fuel oil over to liquefied natural gas, or LNG, This ship produces 99% less sulfur dioxide, 91% less air pollution, and 20% less carbon dioxide. It is an absolutely massive leap forward in the quest to decarbonize global supply chains. But, as you might guess, utilizing this fuel comes with a deeply complex engineering price tag. See, to store enough natural gas to sail all the way from Asia to Europe without stopping, you have to shrink it. By chilling it down to a freezing -161 degrees Celsius, it becomes a liquid, taking up just a fraction of the space. But here are the terrifying stakes. If the tank's insulation fails, and that liquid warms up even a little bit, it rapidly expands back into a gas. In an enclosed ship, that expansion would be utterly catastrophic.
Which brings us to a massive question. How on earth do you keep 20 million liters of liquefied gas at -161 degrees Celsius while sailing through the hot equatorial sun? This tank is 18,000 cubic meters in volume, so vast you could comfortably fit 6 full-sized Olympic swimming pools inside it. Keeping all of that cold is arguably the hardest part of the entire build.
It actually takes 9 whole months just to insulate this tank. Step 1, they line the walls with 27-centimeter thick polyurethane panels to block the outside heat. Step 2 is brilliantly simple. Workers cover every seam with soapy water, place a glass box over it, and use a pump to suck the air out. If a single bubble forms in the soap, they know there's a leak, and they reseal it immediately. Finally, step 3, they install a 1.2 millimeter thin wavy steel membrane. Because -161 degree liquid violently shrinks steel, this wavy design allows the metal to contract and expand without cracking. It's literally the exact same tech used in space stations. How cool is that? Section 4. Building the beating heart. Inside the engine. With the fuel safely stored, we transition over to the rear of the ship to explore the mechanical powerhouse that actually turns that freezing liquid into forward momentum.
The specifications of this engine are just mind-bending. It is the largest natural gas engine ever constructed. It stands 20 meters tall. That's basically a 6-story building stuffed inside the ship. It weighs 2,000 tons and turns out 85,000 horsepower. It is so cavernous inside that maintenance staff literally walk around inside the engine block to check the 12 massive pistons, which are each a meter wide. The crankshaft alone weighs 220 tons and had to be rolled in on a remote-controlled platform with 140 wheels. Now, that giant engine connects to a single-cast 92-ton propeller that stands 33 feet tall. But connecting them, that's a very delicate art. The drive shaft and the propeller must be aligned with 100% perfection. So how do they test it? Engineers coat the shaft in a vibrant methylene blue dye, slide it into the propeller, and then pull it back out. The dye reveals exactly where the metal is touching and where it isn't. Even a single millimeter of misalignment here would cause violent, destructive vibrations at high RPMs that could literally tear the ship apart.
Section 5, Final Assembly and Trials. The hull is welded, the thermos is sealed, and the heart is beating. Now we enter the final external protective measures and the brutal trials required before this megaship is allowed to carry global commerce. Before it can sail, you can't just leave raw steel exposed to the corrosive saltwater and marine life. A rough hull creates drag, which forces the engine to burn more fuel. So workers apply roughly 1 million liters of highly specialized anti-friction paint. They're painting a surface area of 950,000 square meters. To put that in perspective, they're painting an area double the size of Vatican City per ship. That is a lot of paint. Finally, the brain is installed. The command bridge features a system called Smart Eyes, giving the captain a 360-degree augmented reality view of the ship. This is absolutely crucial because, well, you can't see the front and back of a 400-meter ship at the same time. Then come 15 days of punishing sea trials. They test emergency braking, engine limits, and they deploy the anchor. And just think about this for a second. A single link in the anchor chain weighs 300 kilograms. The whole chain weighs as much as 60 African elephants. Against all odds, they passed. They built 9 of these Titans in record time. As the source material beautifully notes, this isn't just a story about bending steel. It's really a story about the meticulous intelligence and tireless dedication of the 10,000 workers who synchronize their efforts like a symphony. They prove that when human beings truly commit to a goal, they can move mountains of steel through the most unforgiving oceans on Earth. And that leaves us with a fascinating final thought to ponder. If this is the bleeding edge of maritime engineering today, using literal space station technology to haul millions of liters of liquid gas just to reduce emissions, what comes next? As these LNG giants conquer the seas today, what will the next 30 years of true zero-emission engineering look like?
How will we move the next generation of mountains? I hope this explainer gave you a deep appreciation for the invisible giants that keep our world running. Until next time, keep your eyes on the horizon.